All right, everybody. So today we have on the show Dr. Helen Kollias. How are you doing?
I'm doing good. How are you doing?
Doing well. So this is really our first time meeting, getting to really talk.
Yeah, yeah,
And now you work for Precision Nutrition, right?
yep, yes.
And so I've been familiar with precision nutrition really since I don't know if it was day one, but early in my health and fitness journey. I remember seeing John Berardi's stuff back on I think T Nation and
Yeah,
different
yeah,
ebooks and things like that. So it's been around for a long time, and I think it's known in the industry for sure. It's one of the big names that's known. So what is some of your background and your involvement with the company, but also just your own individual background?
yeah. So my background is kind of, I guess, less traditional. So I did my undergrad in biochemistry. I was also playing varsity soccer, so I was interested in exercise physiology. Ended up doing my master's in exercise biochemistry, and then was really got kind of ended up going back to kind of more like basic science and looked at molecular biology and cell signaling in muscle development and muscle regeneration, which seems kind of far from precision nutrition. And while I was doing my postdoc at Johns Hopkins, I was reading a lot of John's stuff too
Mm,
through T Nation, and I reached out to see if there was anything like that I could do for them. And I ended up initially writing research articles because ultimately a lot of the basic stuff was still like I had the basic research knowledge to say, okay, well, I'll read a paper and say, well, is this sound or is it not
right.
sound? And we were really actually interested in looking at the genetics of genetic differences, and if we could there was a nutritional component that you could prescribe diet. And
Right.
we could talk about this a bit more later, but the short answer is not really.
Yeah,
Like,
right.
no, not at this time. And then yeah, started doing like writing a fair bit for them. It was 2008, I think, was when I started with them just writing, and was then now I'm kind of ended up moving more towards their certifications, where we're looking at summarizing best practices and research. And yeah, so I think the official title is director of science right now.
Okay.
Yeah, so that was the evolution for PN and kind of training.
Right, right. Awesome. So, yeah, I mean, and going into your background a little bit, it is different for sure and more unique, I think, than some other people I've had on the podcast. And I was looking at some of your articles that you had written, and one that I thought it's a little separate from the typical person who I deal with in the, I guess, fitness industry. And
Yep.
this was the case study, I guess, on The Biggest Losers. And the
Oh
reason I thought
yeah,
that was interesting as I read through it was because, in one sense, like I said, most people who I'm maybe working with don't have 150 pounds to lose,
yep.
but we are often very interested in losing some amount of fat and keeping it off. And that is something that I think a lot of people have a problem with. With bodybuilding, it's interesting because most of the time, especially as a male, there's a planned period where it's like you've dieted and now you want to gain the fat back. And especially, like I said, as a male, I almost feel
Yeah.
like that's maybe one of the reasons that you don't see as many complaints about metabolic damage and things like that with men is because it's almost incorporated into their off season that they're going to gain this fat back and it's kind of part of the plan. Whereas women, they often do want to stay leaner. I think there are more self-image issues there a lot of the time. And so you see that more frequently. But even now, like, having done this, the whole lifting game for a long time, I've even kind of consigned myself to saying I want to stay leaner and not keep doing the bulking and cutting, bulking and
Yeah.
cutting. And it's interesting to see both the psychological and physiological aspects of the body kind of fighting staying lean, and there's increases in hunger.
Yeah.
Obviously, when you diet just from losing weight, you kind of slow down your resting metabolic rate.
Yeah.
And so that the paper you wrote talked about that, but it also talked about some interesting adaptations we saw long term. So just real briefly, can you give kind
But
of
it's
what
if
this?
that it's been a while. Let's see how much I remember. Yeah. So
Yeah,
basically, what ended up happening was, and it could, and this is the thing with this very specific, and anybody, I think almost everybody in the fitness and nutrition world, and most people are familiar with The Biggest Loser, where
mhm,
it's a very stressful situation. It's not what you would consider like a healthy way to lose weight. It's just like
sure.
they're exercising like for hours at a day. I'm honestly shocked that there hasn't been a significant health event.
Sure, yeah.
And they're eating very little. And they're also, I can't remember how much money were they going to win? Was it like 100,000, or I think it ramped up to like $500,000. Anyway, so it was a significant amount of money on the line, and there was ratings involved, and so they wanted they wanted people to lose a lot of weight for this to look really impressive. So I think that's a component that is largely, I think the stress involved with the weight loss will have an impact with it. And I think specifically with this Biggest Loser study, and it was really well done. It was like 5 years, I believe, was the follow-up, if I remember correctly.
6 years.
5-6 years, and so they actually tested them right after, and then they tested the contestants 6 years later. And I was actually surprised that they were able to follow up. But basically what they found was that after 6 years, their hunger cues were still like through the roof, and almost everybody gained back all the weight then some, which isn't surprising. They still had the hunger cues.
Right.
And I can't. And honestly, it's been a while. I can't remember the exact hormones they measured. Was it ghrelin? I think they measured.
They measured leptin, and what surprised me is that. So they showed. I mean, so for people who aren't super familiar, I mean, we see leptin decrease when you diet and
when you lose fat,
body fat, right?
Well, specifically diet's fat. It's related to fat mostly.
Right. And as expected, when a lot of these people gain the fat back, their leptin did go up. Yeah. But what I actually found interesting is, we've kind of, go back 5-10 years, there was people talking about metabolic damage, and then that's kind of been debunked. That's not really damage, it's just a natural adaptation.
But we don't want you to die. Your body doesn't want you to die, basically, and it looks like we're going in that direction.
Right. But typically what we've been taught is like, well, no, that was kind of BS. And like when you increase your calories, your metabolism will come back and it will be fine, especially when you gain weight. Yeah. And it seemed like at least the numbers that they had in this study were showing roughly they were 300 and some pounds, like low 300s, resting metabolic rate of around 2,500. Yeah. They dieted down to an average of 199 pounds. Resting metabolic rate went down to about 1980 or so. And then going all the way back to 270 pounds on average.
Yeah, and they didn't come back to baseline.
That actually really surprised me. Like almost to the point that I was wondering, like, were there methodological errors in the study or something, which I'm not saying there were. It's just that was the first time really seeing such a stark contrast to me. So do we have speculation as to why that would be the case?
Well, I think that why it didn't return is, I think, well, is it the stress as a component? Because what's interesting is it was people like, was it because it was quick? And it's like, well, no, it doesn't seem to, because what's interesting is they've done bariatric surgeries and done similar studies where they look before and after. And with bariatric surgeries, you don't see this weird residual kind of adaptation that you would expect. You would expect all these hunger cues, it's the same things to happen if it was solely weight.
Right.
So there seems to be more going on. People are like, well, what happens if you lose weight slowly? Will that help? It's like, I don't know. I don't know. Like, what was startling about it is, like you said, you'd figure that once they gained back the weight, you'd assume that they would have gone really close to baseline, if not exactly the same.
Yeah.
If it was an adaptation, if it was a true adaptation. But it seemed that now, whether it was the stress or whether it was just the rapid weight loss, that when they came back, their body was still like, it was almost like trying to like protect itself from it happening again. Mm-hmm. Like there's a dysregulation, because it's just and we're talking like significant, like hundreds of pounds.
Yeah.
So I think once you start getting to this really weird extreme, and it's getting more common, but you're on this extreme of physiology. If you are like 2.5 times what would be considered like a body weight where you could function normally, like within let's say 20%, 25% body fat for men. So I think this is a big interesting question mark that I don't know if it would be nice. Well, it's two things. One is like it's one study.
Yeah, sure.
It's one study, and it's a very unique study, and I would like to see it done again in a much more controlled environment. I would like to see a comparison with different weight loss part. Like, is it the weight? Is it the stress? Is it the amount of weight? Is it the rate of weight loss? Is it, like I said, like you looked at it, it doesn't seem to be the rate of weight loss or the weight loss itself, because bariatric surgeries, I think it was like sleeve surgeries, they didn't have this problem.
Right.
So there's all these like it's kind of like, well, there's something else going on. What that is, I'm kind of leaning towards stress. And the other thing too is I don't know how forthcoming the TV producers were as far as what exactly was happening on that show.
Yeah. I mean, but even so, like the follow up was years later, so I would think as far as like the TV aspect wouldn't be a huge
No,
aspect there.
I'm surprised they let them do it. Is what
Yeah,
that's the only part
yeah.
I'm surprised by.
Well, and why I thought it was so interesting is like, for a lot of people listening to this, they know Dr. Lane Norton, and he
Yeah,
was the one who kind of coined this whole metabolic damage term. And then
yeah.
he's since rescinded that. A lot of people kind of crapped on him for that and said, like, no, it's just an adaptation. But when I look
It's almost semantics, but anyway.
yeah, well, that's the thing to me. It's like does it matter like what you're calling it? Like we know what we're talking like
Yeah, but I
what's
think it's the
happening.
perception. I think the perception of it being damaged is that you broke your leg, but in reality, it's like
Right,
your
right.
body is compensating, almost like if you were working out. It's like the scarring and the increase in muscle mass is not damage;
Totally.
it's an adaptation,
Right.
and so that it's more of the connotation of it.
Right. And even when we looked at, you'd hear things like people who have dieted more, like the number of times they dieted
Yeah,
corresponded with like how fat they were. And you could say, if you wanted, you could say, oh, well, continuing to diet causes problems, but it could easily be the other way around, right? It could be that
yeah,
people who were gaining a lot of
yeah,
fat and were more predisposed to being fat dieted more. Both make sense.
yeah.
This is the first thing where I've really seen like actual concrete numbers. And again, it's only one study,
Yeah,
but
why they would
this,
gain back? Why would they would gain back the weight? It's like, well, because they're constantly at a
yeah.
stage where they're hungry and their body's trying to store more fat, even years later and even after they've gotten to the weight that they were before.
Yeah, and I'd love to see more data come out because you don't tend to see this with bodybuilders. Most bodybuilders who diet down for a show, yes, sometimes they get into this kind of binge purge cycle, but a
Yeah,
lot of people who've been at it for, they've had 10 years of competing, a lot of them anecdotally state that they find like the first time was the hardest, and then they get better they almost get better at dieting. I've certainly not noticed, I've had many blood panels done, and when I diet, my thyroid hormone, which would have been interesting if they measured that, but my thyroid hormones drop, and within a couple months they get back to normal, and it's never been that the calories keep getting lower and lower, or anything like that. So
yeah. Well, I think
it's interesting.
that you're probably you're starting at a fairly like healthy body
Right,
weight.
nothing like these people.
Yeah, and I think the other thing too, and I started looking into it later in my research career, but I never really got to pursue it that much, is really the ratio of fat to muscle. And I think really for metabolic health, and this may play a role in adaptation, is that how much muscle you're carrying and the ratio of fat. So really, and I would say that a lot of these guys who lost, it wasn't, I think there was some seasons where they actually looked at body fat, but by and large it was just weight.
Right.
So right, so it's like we're just gonna lose everything, and so you're not having I guess the muscle there that's actually producing adipokines that is really an endocrine organ,
Right.
right?
Right.
And so I think that if you're a bodybuilder, you have that advantage, and how much, I'm sure it plays a role, but how much it plays a role, and also the amount of fat that you've lost and how long this
Mhm.
period of stress is, and so I think it would be interesting to see if you took somebody who is relatively lean and say, well, we're going to lose 5% of your 5% body fat in somebody who's obese, and say we're going to lose 5% of your body fat,
Right.
maintain
Right.
muscle, and then see is there a difference in
Right.
this adaptation, and then can you maintain this thing, and because you start getting below like 15% body fat as a guy, your body's like, no, no, no. No, we're
Right.
not doing this under 10. It's like I don't know what's going on outside, but we're going to try to push
Yeah.
back up to whatever, to let's say 10, 15%, depending on how old you are and your genetic predisposition. So you'd think that if somebody is, let's say, 35% body fat, if they drop down to 30, their body would kind of prefer that.
Yeah.
That would be closer to like what it would be kind of ideal for survival.
Yeah. Yeah. The only other comment I was going to make is it was interesting when looking at the gastric bypass surgeries, and they had noted that not only do their numbers tend to kind of correspond with what you'd expect given like formulas and
Yeah.
everything, but also that they didn't lose any more lean body mass than these people who were
Yeah.
exercising. And I wonder, one, if that just shows the detriment of doing these crazy things like the show, but
Yeah.
also I think they just measured lean body mass, which obviously isn't just muscle. I
Yeah.
mean, a lot of times they'll lose organ weight and water
Yeah.
and things like that. If anything, I wonder if it kind of goes to show that when you're obese, like truly losing muscle is not really a huge concern, because I doubt they were losing a ton of actual muscle. And if the amount lost between gastric bypass surgery and these people who were actually exercising, I don't know if you have different thoughts on that, but for me, usually what we hear is like when you're that fat, you don't have to worry a ton about muscle loss. It would be interesting if they had done, I don't even know what they use, if they use DEXA or what they use, but to actually measure like muscle versus water and things like that.
I think they use DEXA, and I think it becomes a really like interesting thing. And I think that I have you probably have a bit of a bias because I think that muscle is important, right? You want it to be important. It's like, well, I spent all this time, but it could be that you get to a point where, to do it, like really, and to do these experiments are going to be ridiculously long term, like 5-6 years. But you'd want to say, okay, well, we're going to exercise and you lose weight. You're going to do the gastric bypass and you lose weight. We're going to look at lean body mass, and then maybe strength. Like maybe not even actual lean body mass, but say, okay, how? And again, it would have to be a very like kind of contrived strength test, where it's like leg extension. Like they're not going to be doing squats. They're not going to be doing like a whole body thing And so, I think strength, and that's something nobody's really done, is that couple, like, okay, we're going to look at body, like lean body mass, and we're going to look at strength with the assumption that if those correlate, then this, we're feeling that at least a fairly significant portion of lean body mass is muscle, any changes, right?
Yeah.
But, it's interesting, and I find it, like, I think that also it's kind of naive, I think, for people who are trying to coach somebody to lose weight, where they're like, well, you're not trying hard enough, or I've done this, or, and it's like, I think it becomes a very different space at some point where there's a level of dysfunction, and even looking, it was interesting. I remember, I think it was what study was it? It was actually looking at that the fat cell itself ends up becoming pathological once it gets past a certain size.
Oh, interesting.
So that it actually changes in what it secretes. So below a certain size, it's actually, when it secretes things, it's anti-inflammatory, and then once it gets past a certain size, it actually secretes inflammatory. And I can't remember. I'd have to go check and see like which interleukin or
that's really interesting.
So there was this. It's something that never occurred to me, because I think we think of it as just the mass, right? We don't think of each individual cell having a different response based on its size, its volume. But it makes sense that at some point it becomes pathological.
Yeah. Speaking of just, I guess, like different types of fat, before we started recording, you mentioned that you had done some work with brown fat, but maybe not written too much about it. That's actually maybe surprisingly not something that you hear talked about in the fitness industry. Like you were saying, you were surprised nobody's tried to market it, right?
No, there's no supplement to activate brown fat. Like, why?
Right.
We can start one.
My understanding is most of the research is in mice, but to be honest, it's really not an area that I'm super familiar with at all. So maybe you could educate us.
It was a really fascinating thing. So in 2008, up until 2008, and probably when you went through undergrad and school, it was like, well, only rodents and babies have brown fat.
Right.
Yep. And up until 2008, that was kind of like the conventional, not like wisdom. And then I think it was 2 papers came out. Barbara Cannon was like one of the lead authors in the one. And what had happened is, and this was done in humans, they did PET scans with a specific. It was actually originally it was done for cancer, to find cancerous tumors that cancer does use glucose predominantly, and it was radio labeled glucose. And then they found these spots light up. And then they're like, well, you thought it was just cancer, but then you can inhibit it with beta blockers. So like, wait a second. And then the technicians are like, yeah, we see this all the time. And they're like, what? Yeah, we see it all the time. And it turned, they thought it was just an artifact. But it actually, they went into it and they looked at it, and they took samples, and it was brown fat. And so brown fat, for people who may not be familiar with it, is this really interesting tissue that is very much this, almost like the mix of fat and muscle, in that it actually does produce like actin and myosin. It doesn't use it, but it actually does it, and it has a lot of mitochondria. It does store fat the way like white fat would, but it's very metabolically active, and it usually is kind of associated with keeping you warm, and that was kind of the, as with small animals and babies, they need to stay warm.
Right.
And it could still be a component in adults, especially the original spots that they found were like near the neck. And so places that you might want to keep warm, like obviously the neck, you maybe want to keep the blood warm going to your brain would be important.
Right.
But they've the other type of brown fat that they found is actually found in visceral fat, and it's converted. It seems to be either converted from pre-adipocytes or converted from actual like mature white fat. And that became really interesting because it became a question of like, well, is this why some people like are metabolically healthy at heavier weights versus other people who are not? And also brown fat has a ridiculous amount of mitochondria. And it's just this basically a sink for calories, which is why I'm surprised nobody's tried to use it in the to activate it in people, where it's like, here, this is an activator of brown fat, even if they're, clearly, the supplement industry doesn't actually have to have any proof for any of this, but it's a good story. And so what they found, what was interesting with this is that they found that lean people tend to have more active brown fat, especially when they're exposed to cold, compared to obese individuals. And this was all the original 2008 papers. And it became, again, chicken or the egg kind of a thing, do people who don't have active brown fat or as active brown fat more likely to gain weight and become obese versus people who are lean? So there is a lot, like, it's interesting actually why part of the reason that you can actually activate brown fat by eating spicy food to a degree. Like, this is not like this is not like you're going to start downing, jalapenos and then like lose weight, which I'm sure somebody has tried. And then the other thing is the idea that to be outside would make you cold and then you would lose weight. It doesn't seem to work that way. There seems to be.
I have heard that one. Yeah.
Yeah. So then it makes no sense, right? Because then people who are like living at the equator, they should be much heavier than people who live like further. As you go north, there should be a really nice like BMI graph that basically people like skinnier, and then everybody would just go up north to lose weight. So brown fat, I really found the most fascinating thing about it, though, was it really like that had expressed it made like actin and myosin and muscle-specific proteins that it never uses, and it was just like really fascinating. And there's a whole field now trying to figure out how to activate brown fat in like white fat to basically convert it, and then it can improve the metabolic health of the individual, at least in rats. They haven't been able to do it for ethical reasons. They haven't done it in people.
Right. So as of now, there's not really any implications in humans. I mean, we see it, but as far as like any way to benefit us, really.
I think what likely will happen is we'll find a lot of things that people do, like, eating more protein potentially, like, or exercising probably activates it. So I think things that you would do to lose weight would activate it to one degree or another.
Right.
And so it's gonna, and it might be there's things that, so it tends to be activated through sympathetic nervous activity, which is why beta blockers stop it. But then you're like, if you're stressed, this should be good, right? Because you're having an asynchronous, and it's like, well, no. So there's like a lot of counterintuitive things. Women tend to have more brown fat, which again seems very counterintuitive because if it's metabolically more active, you figure that women would be leaner. And so there's things that are very counterintuitive with it, and there's still like, it's been about 12 years, but it's still, they've gone really down the mechanistic pathway to try to figure out how exactly to turn on, how to do all this thing, because clinically it's very difficult to measure how much brown fat somebody has, because you'd have to stick them in to get a PET scan, and there's only so much radiation that people want to be exposed to. So, and that was the other, when I left, they were looking at, basically that was the big push, is try to figure out an easy clinical way to measure brown fat activation. And to my understanding is that hasn't happened, and until that happens, I think we're going to be kind of stuck with animal and a mechanistic model.
Yeah. I mean, that's always, I think, kind of like the start of research and interesting. We see that things work, and like you said, maybe a lot of these things that we find result in more fat loss. One way that it did it maybe was activating more brown fat, but that doesn't necessarily mean that we have a way to, really manipulate things to do right, exactly, until like for the time being. But it gives us maybe ways that in the future we can manipulate it, which is cool.
Yeah, and they're like they were looking for a lot of drug targets, and I don't think they've found anything as of yet. And then it was like, well, exercise and in nutrition,
right,
or a potential drug target that we haven't, or drug that we haven't figured out yet. So I'm like,
right.
This might be easier to do. But
yeah. Speaking of which, I know my understanding, it's been a little while since I've looked at this, but I believe that when we look at mice without, like when they knock out leptin, they tend to be pretty obese.
Oh yeah, it's crazy.
Yeah, but my understanding is also that giving leptin does not tend to result in a lot of fat loss. Am I remembering that correctly?
No, it works great for mice.
Even in normal leptin.
Yeah, in a normal leptin. So if you have a leptin knockout mouse and they give them leptin, they will lose weight. If you feed them and you give them leptin, they tend to lose weight. And there is cases where you can make a mouse leptin resistant, but what happened was, right, you probably remember, it's like leptin, we solved it, right? Like
right. At one point they thought it was going to be like the miracle.
Yeah, and so then it was like, oh, leptin resistance. Oh, like, so really I kind of look at it between type 2 diabetes and type 1 diabetes, where type 1 diabetes is like you just need insulin to regulate your blood sugar. And so if you didn't have leptin, which there are humans who don't have leptin, they're not producing leptin. So if you just give them leptin, then they'll lose weight.
Right.
But those are very few. So that's kind of like not having insulin, the type 1 diabetic. But by and large, most people are leptin resistant. And again, it's a bit of a chicken or the egg thing, is like, if they're leptin resistant, do they gain weight, or did the weight gain cause the leptin resistance? Right. And then exercise and, like losing weight tends to improve leptin resistance. Right.
So there again.
So it was like the holy grail there for a couple of years, until they realized that very, very few humans they thought, people who are obese must have a mutation in their leptin gene, and that wasn't the case. And it was leptin resistant. See, it's more complicated.
Right. Now that makes sense to me. If you're leptin resistant, then just giving more leptin isn't going to fix the issue. Now, so what you're saying is in knockout mice, giving them leptin, obviously in that case, helped just like it would in a human. But for mice that had, let's just say, like normal genes for leptin, who were not overweight, did giving leptin make them even lose further weight?
I would have to look if they ever looked at normal weighted mice and compared, because I think it seemed that the story was simpler in mice.
Mm-hmm.
And it was, lab mice, right? Whether this would play out in a more like, wild mouse situation, but yeah, it was for sure. It was like overfed mice, and it was also done in leptin knockout mice. But I don't know if they were already lean. If you could, can you basically drive it down?
Right.
It's like have the shredded mouse.
Well, that's what I would wonder from like a bodybuilding standpoint. Like professional bodybuilders, obviously, who don't compete naturally, they look for everything they can, right? So they could be totally euthyroid, but they'll take thyroid medication. They'll take things that they don't need. And I'm almost surprised that I've never really heard of.
It's probably too expensive. Like you would have to.
Yeah, that's the other thing. It's not like it's readily accessible. So
yeah, they would have to. And I don't know if they probably have it for research purposes, but I don't think it's ever been available. Because again, I think there probably is a few clinics that have it available. It's ridiculously expensive again, I'm guessing, because how many people are using it for clinical application, like for actual treating of patients. So it's probably like steroids are cheaper.
Yeah, certainly.
As effective.
But even as if you look at those the obese individuals, going back to the Biggest Loser, I would assume that as they lost that 100+ pounds, they became less leptin resistant.
Yeah.
And so then maybe in theory, if after they dieted down, they were given leptin, that would then help them.
Go further,
or even just help them maintain, rather than have the fat gain.
Yeah. So their body is we have you're kind of artificially telling the body that there's extra weight.
Basically, yeah. I don't know.
It's we have, and so as a treatment, so you use it as a treatment. So when they they wouldn't gain weight because the body, you're kind of tricking the body into believing it already has gained weight.
Right, once the resistance has gone down. So
That's actually that would be a really cool, I think, like, study
I
for
think
you.
we just solved it. I think we
just solved it. Exactly.
just discovered the solution. So yeah, that'd be something to look into. We did kind of talk about, going as far as like resistance and intolerance. One of the other articles I read by you was on carb tolerance and intolerance, and that's I think a term in the industry that some people just think I don't tolerate carbs. And I think a lot of people who were at one point heavier or fatter, like I was as a kid, you just assume you don't tolerate carbs. And I remember there was a lot of talk on like how, well, maybe you should use a ketogenic diet to bulk up because that'll keep you leaner. Even, and as somebody, again, who is always was like skinny fat growing up, I thought that made a lot of sense. In my experience, actually, when I've tried to bulk up with very high fat, lower carb diets, I actually seem to gain more fat proportionally. And so I don't think it's as simple as, oh, well, you put on fat easily, you're carb intolerant. So when we say that people have this carb intolerance, what are people really meaning, and what does that imply?
Well, I think what people mean, I'm not sure, but with this article, it was actually specifically looking at this amylase gene. Mm-hmm. That they were looking at how, and that wasn't a mutation, it wasn't any polymorphism, it wasn't a difference in the sequence of the gene itself. It was just how many copies of this gene do you have, and it's called AMY1 is actually what the gene is called. And so with AMY1, you can have, what was it, like 3? I can't remember. I think it ranged from like 1 or none to like 14 or something copy numbers. So the idea is that more copies you had, the more your body would produce of this of the amylase. And amylase is just something that breaks down carbs. Right. And it turns out the more copies that you had, you tended to live in regions that had like agricultural, like, I guess, an agricultural culture sooner or earlier, like so Japan. Where there's a lot of rice and traditionally there was a lot of carbs in your diet, they had a lot of amylase, like a lot of copy numbers, and it didn't seem to correlate with increased body weight. While you had other regions like northern Russia where you're like very, very few copy numbers, and they traditionally had a low carb diet culturally, and they also didn't have much of an agricultural culture where they didn't grow. They basically were hunter and gatherers for the most part, and they ate a lot of meat. And so from that perspective, there seems to be at least a genetic component. And then they also looked at if you had more copy numbers of amylase, you seem to be more insulin sensitive. So, and why? Who the hell knows? Like there was a lot of like, hey, this is really cool. We have no idea why.
Yeah.
And so I think that is a component where there is an underlying genetic reason why people could be. And I think, well, the problem is with a lot of genetic stuff is that one gene or a number of copy numbers of the gene is like one very small piece of a much larger puzzle as far as, let's say, regulating, carb intake or carb metabolism versus like fat metabolism or whatnot. So I think so there's like that's a genetic predisposition, but I would argue that if you could, there's it's a predisposition, you can push yourself one way or another. And that's probably what happened with you, is that maybe you were quote unquote carb intolerant, but by shifting to some degree, like what you ate and how you worked out and really the proportion of muscle to fat, then you kind of shift how your body's able to metabolize carbs and fat. So I think it's possible. I think a lot of the tests that people use or claim to use don't hold any water. And this study that came out, and I haven't followed up on it lately to see where this research went, but amylase it seemed like such a benign kind of like, this is just an enzyme. It's not like regulating anything really. It's just breaking down. And this was actually, it was specifically like the amylase in your mouth. Right. So it wasn't like pancreatic. It was like, well, what the hell? Like, it's like, why? And so this idea that but why? That became the interesting question. Is like, why would it matter? Like, is there other genes that are associated with this? But why would it matter if I can break down carbs more effectively in my mouth? Right. Like, it would make sense while you're eating more carbs, and then you'd want to eat more carbs maybe because it would taste slightly sweeter. Mm-hmm. But that would be a pretty good argument against being tolerant to carbs, because you would start eating them and it feels sweeter and you would eat more and more, right? So it became this really and that's what happens with, I think, most researchers. Like, this is really cool. It makes no sense.
Right.
And we have no idea what exactly is going on, but it's really, really interesting. And that's really where I think from a genetic standpoint, where the carb tolerance is. Like, there's a lot of really cool things that arguably make very little sense if you start like thinking them through. It's like, why, but what, like how, but why? And then also, I think there's going to be a huge layer of like epigenetics, which is the impact of lifestyle and even what your parents' lifestyle or grandparents' lifestyle was on how your genes are being expressed.
Right. Yeah, I mean, I think one of the really interesting things, I mean, people know that I talk about genetics a lot. And it's not to give this excuse. I mean, it's tough because a lot of people don't need to hear that, oh, maybe it's your genetics or something. A lot of people, even if it's true, it's not necessarily completely helpful. However, I do think, I mean, sometimes it can be helpful, but I think from like almost from like an empathetic standpoint, I think it's good to know that genetics have such a huge influence because there are people who really are trying very hard, who are going to struggle a lot. And for somebody who it just comes very naturally to, they might never really understand that unless they become a coach perhaps and have, hundreds of clients and they've seen, oh, this person really is trying. I mean, a lot of times you see that somebody who's never trained anybody and just has great genetics or something, it's hard for them to relate. And that's not just with like bodybuilding, that's sports, that's other things that aren't physical endeavors, intelligence. If you're just an amazing student, you might just not understand. Well, just study more.
What's your problem? This makes sense. Like, this is
right. And
you're just not applying yourself. It's like, no.
Right, exactly. And I'm sure we've both seen that in our schooling where some people it just didn't come to them, and other people it came very naturally. And so with the whole like fat loss thing, I mean, something that I've talked about before is when I was maybe 21, I was prescribed thyroid hormone, and I always said it was done a little bit prematurely. I think, I was probably tested too close to when I was finished the diet, and I think as a 21-year-old, I wasn't really that skeptical. I was just like, well, okay, if you think I should take it, I'll take it. And it was amazing to me how much it changed a lot. I mean, in terms of like my sleep, my hunger. I have never been more ravenous in my life. My hunger was through the roof. It was the first time I'd ever like cheated on my diet after like 10 years of like priding myself on never cheating on my diet. It was just like, I don't know, it was just crazy. And then also how quickly I lost weight. I mean, just so many things changed from that one hormone. And so you got to think like for somebody who's maybe naturally on the very high end or very low end, or how many other hormones and neurotransmitters and enzymes vary genetically, you really don't know how difficult or easy something is for somebody. And so again, not to just let people off the hook, but I just think it's important to remember that your experience can be very different than others.
Well, yeah, and I think what ends up happening is it's ultimately, I think what happens is sometimes people think, well, it's my genetics and therefore I'm not, maybe I need something special. And the reality is like the foundational fundamental things don't change. You might not be responding as well as someone else, but you kind of like, you need to be in a caloric deficit. You need to your basal metabolic rate may be really high, but and so you don't have to work very hard to get that, but this foundational things that need to be done, and it may be harder. It's like, it's like if you're running a marathon, it's all the same. You just not be as good at it.
Right. Yeah.
So it might take you like 6 hours to get through it versus like, a 2.5 hour or 2 hour runner. But the fundamentals are the same. You still have to travel that distance, and you still have to. So I think genetic predisposition is like a huge factor in like how your body responds.
Right.
But I think what a lot of people like, well, I'm going to get a genetic test, and then it's going to tell me what I should eat and what I shouldn't eat. And I kind of feel people are like, they want to hear that they can smoke and then watch Netflix. This is going to work.
Right.
But the reality is like, it's going to be the same. Like, but not the vast majority is going to be the same. And the minor variations are not, at this point, we don't know enough to say, okay, well, this is how all the things interact. And for you, if you did this combination, which I don't think is ever going to happen. I don't think they're going to find like, oh, well, it turns out that you're really unique. Mm-hmm. And if you eat apples and then pork and this other thing, and then you have to do it like 2 times a day, but you can do something like that. It's not going to be that clear, and it's not going to be that different.
I agree. I mean, yeah, that's a great point. It's like how you're going to respond is going to vary dramatically, but what you have to do is probably similar. Not that there's no differences. I mean, of
Yeah,
course, like, they look at the studies and some people respond better to high frequency training versus
yeah,
low or high volume versus low. And I'm sure, in terms of even macros, like overall, most of the studies seem to show that calories and protein are much more important than trying to manipulate specific carb
yeah.
versus fat ratios. But I'm sure there are people who individually respond better to higher fats or lower fats, et cetera. But ultimately, yeah, I mean, the fundamentals are still going to be there, and it doesn't sell as well. It's nice to say based on your genetics, like this is what works for you, or we need
Yeah.
to manipulate these hormones. But ultimately, at least as of now, we don't have that. And so,
Yeah, and I don't. It was really interesting because I kind of towards the tail end of my research career was when epigenetics, really the realization of how much impact of epigenetics and even transgenerational epigenetics came to be, and it was almost like all the geneticists are like, oh, like, oh no,
right, yeah,
like oh, it's like so it's all that stuff, and now it's like, well, it could all be overridden.
sure,
And so so to have like, let's say, only looking at the genetic component of it is like, well, if everything was on and there was no epigenetic layering on top of it, then
right,
yes, that may be true. And so I think that, and a lot of it, people are like, well, should I get tested or not? I'm like, well, I think you can kind of figure it out. Like, I think you
yeah,
have, you kind of like, well, like you said, like you tried it and it worked or it didn't work. So you like try low carb and does it work for you? And then it's like, does it matter if it's physiological or psychological?
yeah,
Like people always keep on pressing, especially with the ketogenic diet. It's like, I don't know, I'm like, I don't see the data that shows that it's all that special, but if it's working for you, then does it matter?
sure,
Like,
totally.
does it matter that like there's a paper
Yeah.
that supports
Yeah, I
it?
think it matters maybe from like a research and mechanistic standpoint, but
Yeah.
from an individual standpoint, like and some of us, like, I'm a very curious person. I like to know why things work,
Yeah.
but ultimately for 98% of the population, it's kind of like, did it get you the results or not? And it becomes a problem, I think, when you have these like internet flame wars and you're like, well,
Yeah.
keto worked for me because it manipulated insulin and I could eat
Yeah.
all the calories in the world
Yeah.
and it still worked. It's like, maybe not. But like you said, ultimately, if you're looking for results, it just
Yeah, it doesn't matter.
it's
Yeah,
not
but yeah,
simple.
it does drive me crazy where it's like, well, why? Like, why is it like, you'd want to see how what exactly people do when they
Hmm.
go on these diets, because I think people's perception is different than, like, I've catch myself going, is this true? Like, am I eating more? Am I eating less? And if you're not really tracking very religiously, like all the time,
Yeah.
then you really can't say for sure what you're doing. Like, I think
Right.
it's a really, I would argue that at this point, for you to be successful on that diet is that you have to have buy-in and it has to be caloric deficit. And your
Yeah.
buy-in will basically and that's why I think diets have become kind of weirdly the new religion,
Yeah.
where people are very like they just buy in wholeheartedly, and I just have faith in this diet,
Yeah.
and it's worked for me, and it works for you because you have faith in it.
Right. Yeah, for sure. So as far as like, the future of research in this realm, it could be as psychological or physiological. Is there anything that you're particularly excited about on the horizon?
For like the genetics and obesity kind of
Or
thing,
or
or
even
just
just, yeah, I mean, as far as like, your work with precision nutrition and coaching and things like that, like as far as for this world of people, mostly, let's say, looking for like fat loss,
yeah,
is there
yeah.
any research that you find exciting out there?
Uh, like all of it is really interesting to me mechanistically, like because and I would like to see how it all fits together. But I really think like the appetite regulation stuff, and there's like a lot of like a lot of the genetic stuff with that's linked to obesity is actually more like cognitive,
Mm,
like linked to cognitive. It's not linked to metabolism, which I
yeah.
think people like are like always looking at that side of it, but it seems to be more likely to be like some sort of like reward, like dopamine kind of regulatory
Yeah.
factor or gene. And so that I haven't looked at it much recently, but that area seems that the most interesting from a genetic mechanistic kind of standpoint, because I
Right.
think that ultimately that will be it. That will be, I think what will happen is it won't be anything like, oh, there's this gene that impacts thyroid or basal metabolic rate or whatever. I think it'll be a reward.
Yeah. Yeah, I think the psychological side of it is really interesting. And I think even just, I mean, there's a physiological aspect there as well with that, like as far as, the neurotransmitters and
Yeah.
all that. But a lot of times people will say, "Oh, my metabolism's blank, right? I can eat so much, I have a fast metabolism or slow." And I usually what I say is like, "Well, your metabolism can be different than others, obviously, but the largest factor is going to be your body weight typically and your muscle mass, and there are going to be variances, but a lot of what people don't consider is hunger and things like NEAT, right? Like non-exercise thermogenesis. Because the hunger thing is huge. I mean, most people don't realize if you're somebody who just has a low appetite, you see this with like the teenager who seems like they can eat anything they want, and they probably are eating a lot, but you don't notice that, well, they just ate a whole pizza, but then they didn't eat for like the next day. Right, yeah.
Because that's what I would do. I'm like, I can't gain weight. And it's like, well, you didn't eat breakfast because you're like,
right.
I tend to get distracted and I just like forget to eat. So it's like, well, if you're doing this on a regular basis, it's not like you have a fast metabolism. It's just like you're not actually eating, and again, it becomes down to like maybe a reward mechanism or your like whatever the driver is for you to eat is not as high, and also stress. I think the stress response is a really interesting one where I think that some people when they're stressed just don't eat. They're just like, I'm not eating, and other people they will eat as to deal with stress. And this was interesting. It happens a lot it comes up with postpartum and breastfeeding women. Like there's women postpartum that will lose weight breastfeeding and lose almost too much weight. And then there's women who like struggle to lose weight after and they're breastfeeding. So women ask, well, what should I do? And it's like it kind of seems that you kind of have to just like if you're not losing weight and you want to lose weight, you kind of have to wait until you're done breastfeeding because it's either lack of sleep or stress or what. Like it's a big question mark as far as why and there isn't any research. It just seems from speaking to women that they struggle to lose weight and then they stop breastfeeding and then they can lose weight. And so stress could be an underlying component to that. Yeah,
stress is a huge one. Sleep, which then could tie into how you're adjusting to stress. But yeah, I mean, just when you're hungry, you're just aware. Like right now, because I just finished dieting recently. So if I eat, let's say 3,000 calories on a given day, I might still be very hungry. Whereas if like in the off season bulking up, I might eat 3,000 and not think about food all day and almost be like, oh, wow, I have to actually make up for it at the end of the day. And, that latter one, I'm thinking to myself, wow, I'm eating kind of whatever I want because whatever I want is way less,
Yeah. Well, that's the thing too, right? Is that people who like if you're trying to gain weight, and I think eating, and I guess it depends where your I guess hunger cues lie. If you're like tend to forget to eat or not. Yeah. But I found like trying to force myself to eat was just like horrible.
Yeah.
It's like you're like I'm full, and your body's like we're done. You're like no.
Yeah, it's like I gotta come back to this like in another 10 minutes or something because I can't go right now. Yeah.
So sure. I think it's a really interesting kind of weird world that outside of like sport and bodybuilding, like mostly like let's say football and sports that kind of need mass.
Right.
I think the idea that you would actually try to gain weight is just
a little really out there.
Weird. Yeah, because I was like I think it was 10 years I was trying to gain weight for basketball, but I was just wasn't eating enough. I wasn't really interested in putting that much effort in eating enough. And then again, like you said, you have to track it to know where you're at. And I think people misunderstand the idea of like, I think you have to track, but you can't be fixed on the specific number. Yeah. Like, so if you're like 3,000 calories is what I'm supposed to hit, and you're hitting 3,000 calories and you're religiously doing that and you're not hitting and you're not gaining weight, then you need to eat more. Up.
Yeah.
And people are like, should I do another equation? Should I do a DEXA? Should I do like, I'm like, no. Like,
yeah, just eat more.
Eat more. And then it may not be that you're eating 3,000 calories because maybe your numbers are off a little bit. But it doesn't matter. It's like a teeter-totter, right? You just kind of like if you're trying to balance it, you just put kids on each side. You're not bringing out a scale, right?
Yeah, I never understood the obsession with the equations. It was one of those things where it's like, it's still to this day, I see people say, well, what equation do you use? How do I calculate it? And it's like, it literally doesn't matter. Whatever you're doing.
Start a number and start eating
Pick a number. Right, yeah. Look at the scale and, be consistent with it and then either eat more or less depending on what the scale is doing.
I find that people feel that if there's an equation involved, then it's more accurate.
Right, like it's right,
Yeah, exactly. And I'm like, no. If the outcome is not what you want it to be, then that is actually your measure of accuracy. Are you going in the right direction? And yeah, I get it all the time. People are like, what should I use? Should I use like indirect calorimetry or this or that? I'm like, no.
Right.
Right. But like if your client wants to lose weight, how much are they eating right now? And try to accurately like get the portions, and even the calories don't necessarily, but get like the portions and then just eat less of that same food.
Yeah, if you're eating a lot of the same foods, I think that's
Yeah.
the way to do it. Obviously, if you're eating a ton of different foods, it gets a little bit more complicated.
Yeah.
But
Most people eat about the same 15 foods.
yeah, they really do. Day in and day out. I know people who try to incorporate a lot of variety, and they usually get tired of it. It becomes almost annoying. Like I think,
It's effort. Like it's a ridiculous amount of effort to go.
yeah, it is.
I'm gonna eat a different vegetable. It's like, oh, okay. Well, how do you cook this vegetable? How does it
Yeah,
last? Like, where is that? Okay, now we've like, yeah, we know, like, yeah. So I think the novelty of,
yeah,
yeah,
it
like,
gets old.
yeah, well, yeah. It's a weird, yeah. It's too much. I think, what is it, like decision fatigue?
Yeah, yeah, for
Like I
sure.
just want to eat. It's like wearing the same clothes. It's like I just want to eat the same thing, and I have like maybe if you're lucky, I think people have 20 recipes, go-to recipes for
Yeah,
food.
if even that. Yeah, right,
I
right,
think, but most likely, I think 5 are going at any given time.
right. Yep. All right. So this was a great talk. I really appreciate you coming on to talk with us today. And for people who want to find out more about you, see more that you've written or what you're doing, where can they find you?
Precisionnutrition.com, and that's probably the easiest way. The blog there,
Perfect.
and then yeah, I think that's about. I don't know if they have an author page yet. There's some talk
Okay.
there.
All right. Well, yeah, I'll look on that and I'll have links to everything below.
Cool.